Pranav,
This is Archana.
and today we're going to be talking about printed circuit boards, also known as PCB, and the design of it using the yield software and printing it using the other mill for all prototyping purposes. And we'll be doing this with the design of the A-stable, my 555 timer IC circuit, and we'll be blinking an LED. So Eagle is CAD software, and we're going to be dealing with the freemium edition, which has basic restrictions of 100 by 80 millimeter and 4 signal layers, but for a hobby person is for all hobby users, it's quite enough.
Let's have a look at the software. This is where you're gonna draw the circuit, which is where you lay out the components that you need and the connections between them. Here on the left side panel, we have all uh, the drawing aids that are required to make a circuit, and this button is going to take us to the library from where we add our components. So library is a collection of the devices that are used in making a circuit. It has two things. One is a symbol, that where it shows a general LED, and a package which shows what it's going to look on a PCB layout. So the symbol is for the schematic only, whereas this is gonna come when we convert the schematic into a PCB layout.
Okay, so before you start out, you need to have, first of all, the circuit in front of you, and this is what it looks like. And we see that there are some components missing, so we'll just add that. We've already made the circuit, but we've deleted certain components. Okay, so for resistors, the basic general library I'd recommend is the RCL library with RUS, and okay. Also, we're going to be needing an LED for the output. Five millimeter. So generally, in bigger circuits, we can't make all the connections physically, so you can also just create a label, and it automatically detects it. Okay, so now we can just go File and switch to board. Switch to board. There we go. So we have this PCB layout ready almost, and I mean the placing of the components. Obviously, you first always place the components. In more advanced areas, when we get more advanced requirements, that time we design the PCB using thermal concentrations and placing the components using thermal concentrations, but for our purposes and all general purposes, it's not required. So yeah, so place the components as you might consider necessary. Now this is the tool that we'll be using, routing. Okay, so now if you see this, there is a slight problem in this, and I would suggest you to have the drill size or the pad size, which is this green color diameter, at least twice the size of the drill itself. So we can go to this library. So what we're doing over here is we're going to go to the library, we're going to go open package, and we're going to essentially change a part of the library. So you see this diameter is 0. Let's at least make it 0.66 and round, yeah, shape round. And the drill is 0.032, which is the standard drill, which is also um, available with the other mill. It's 1 by 32. So I have done all of this. Now we'll go back, cancel this, and now it doesn't reflect here, so we could just do library, update all, and you see, okay. Now we'll use this connections over here, this net, and just make the connection. Now always PCB design guideline, never have the tracks 90 degrees to each other. Instead, if you right click, there are options that come. This, never have it at acute angles or 90 degrees as much as possible, because that creates a lot of excessive current flow or excessive heat generation because of sharp turns that the electrons have to essentially follow. Also, while routing these connections, make sure that the distance between two copper parts like this and this should be a minimum of the size of the mill that you'll be using. And the mills that we have at the Maker Lab, the least size is 1 by 64 and 1 by 32 is sort of preferred to use. Of course, the thinner the mill, the end mill point or bit that you use, the slower your PCB is going. More time your PCB is going to take to print. Okay, so now you see this, the layer that we are using. Okay, I forgot about mentioning the concept of layers. If you see all of these, there are many layers in PCB in the software, and for most general purposes we'll be using, especially for printing it on the other mill, is the top, bottom, pads, wires, and dimensions. Of course you can use T-place and origins, but then that doesn't help the PCB miller at all. Okay, so this is essentially what your PCB will look like, but in order to get a little more clarity, just get the ICs also into the picture. Also, we have been instructed to use only the top layer for single-sided PCBs, so we're going to go ahead and use that, and we're going to convert all of this into top layer PCB. Of course, I'm going to show all for the time being. Right, so here we go. Make sure you're using the top layer. Of course, you can change it with this press of the scroll button. You see that the color changes. Okay. While routing, you can also change the size of the track like this if you don't have enough space. But then I wouldn't suggest you to go too small, as this can be easily eroded off the PCB and not give you enough hold on the PCB itself, and the tracks can easily get eroded. Of course, if you want to measure the distance, there's a button called mark, and you can easily measure the distance from here. If you go down, you'll see that. Okay, now we'll have to change the scale. Let's make it the finest possible. Again, mark it. So mark this part, and then let's see this, which is roughly 0.011, and if you see 1 by 64 is 0.0 0.15. So this